Status.
Bodyguard.
Commander.
Rico.
Mission.
Mission. We're going to war.
Welcome to the Toys of War, a concise review of some of the modern trends in military research, military hardware, and the latest developments in military industry.
Blue Halo is a US-based defense technology firm specializing in next-generation military solutions. The company focuses on counter-UAS, unmanned aerial systems, directed energy weapons, space-based systems, artificial intelligence, and cybersecurity. Known for its agile innovation and rapid prototyping, Blue Halo serves government and defense agencies, bringing cutting-edge solutions to evolving modern warfare. The Freedom Eagle 1 is Blue Halo's newest missile platform tailored for countering Group 3 and larger UAS threats. Designed for speed, accuracy, and adaptability, it is an all-up-round missile system with compact size and rapid response capability. The FE-1 features advanced guidance, navigation, and control systems and is suitable for deployment on mobile ground vehicles and fixed platforms, making it versatile across different terrains and scenarios. Primarily designed for anti-drone operations, the FE-1 targets medium to large-sized drones that pose threats to forward operating bases or critical infrastructure. It can be rapidly launched to neutralize threats in a dynamic battle space. The missile's agility and scalable design hint at potential modular compatibility with future multi-domain defensive systems. Its compact form allows integration with expeditionary systems without compromising firepower. In January 2025, Blue Halo conducted a successful fire test of the Freedom Eagle 1 at Yuma Proving Ground, launching 3 missiles that met performance targets. The demonstration was part of the U.S. Army's Next Generation CUAS Missile (NGCM) program. Following the success, Blue Halo aims to host a fire demonstration for military stakeholders in the third quarter of 2025, suggesting operational deployment could begin shortly thereafter, pending evaluation and procurement. The Dragonfire laser weapon system is a British-led defense technology initiative developed under the UK Ministry of Defence Directed Energy Weapons Programme. Initiated in 2017, it's a collaboration between MBDA Project Lead, Leonardo UK, Target Acquisition and Tracking, and Kinetic, Laser Source and Beam Director. The system is designed as a high-precision, low-cost alternative to traditional missile-based defense solutions. Dragonfire is primarily intended for naval deployment, with integration plans focused on Royal Navy surface vessels. Future platforms include Type 23 frigates and the newer Type 26 and Type 31 warships. The system is capable of targeting and destroying small, fast-moving threats such as drones, mortars, and possibly incoming missiles, making it a highly flexible point defense option in contested environments. The laser weapon offers advantages in speed and cost, striking targets at the speed of light and with a per-shot cost as low as £10, compared to traditional missiles costing over £1 million. However, laser weapons like Dragonfire are sensitive to atmospheric interference. Rain, fog, smoke, or heavy cloud cover can reduce beam focus and operational range, making environmental conditions a notable limitation. Initial fire trials were conducted successfully in 2023 and early 2024, proving its ability to track and neutralize drone targets with pinpoint accuracy. The Royal Navy plans to install Dragonfire on 4 of its ships by 2027, advancing the program by 5 years. Full operational integration will likely continue into the early 2030s, supporting broader adoption of directed energy weapons across UK defence forces. The Viper Experimentation and Next Gen Operations Model Program marks a bold step in the U.S. Air Force's pursuit of advanced autonomy in air combat. Initiated under the banner of Collaborative Combat Aircraft Development, Venom serves as a real-world platform to test AI-piloted and human-machine teaming concepts. Its primary aim is to integrate autonomous agents into fighter tactics without replacing human pilots, instead enhancing their capabilities. The program utilizes 6 F-16 Fighting Falcons, modified for AI integration and autonomous flight operations. These are not just any F-16. They've been fitted with cutting-edge sensors, updated avionics, and onboard processors capable of running advanced autonomy software. A key feature is the pilot override system, ensuring a human can take back control at any time. The aircraft also have upgraded data links for high-speed coordination with other crewed and uncrewed assets. Venom is designed to evaluate how AI can handle dynamic combat scenarios, everything from one-on-one dogfights to two-on-two team tactics. The goal is not to build killer robots, but rather to develop trustworthy wingmen, unmanned partners that can fly alongside human pilots, adapt to threats in real time, and share combat loads. These tests will help define the future of tactical air power, where machines act as force multipliers, not mere tools. The U.S. Air Force has allocated $50 million for the Venom program through its fiscal 2024 budget. Initial flight tests began in mid-2024 with a projected test window of 12 to 18 months. If successful, findings from Venom will directly influence the development and deployment of CCAs in the Air Force's next-generation air dominance (NGAD) strategy, likely maturing into operational roles by 2028 or earlier. In March 2025, during the annual Freedom Shield exercises, U.S. and South Korean forces conducted joint drills in Paju City, focusing on combat scenarios involving North Korea's extensive underground tunnel networks. Approximately 370 troops participated in these 4-day exercises, which incorporated advanced technologies, including quadrupedal unmanned ground vehicles, commonly referred to as robot dogs. These robotic systems have been integrated into military operations over the past few years. The U.S. Air Force began testing Ghost Robotics Vision 60 robot dogs in 2020, deploying them for base security and reconnaissance missions. South Korea has also adopted similar technologies, collaborating with domestic manufacturers to develop and deploy robotic platforms suited for their defense needs. Major manufacturers in this field include Ghost Robotics and Boston Dynamics, both of which have contributed significantly to the advancement of quadrupedal robotic systems. The recent conflict in Gaza has underscored the strategic importance of tunnel warfare. Hamas' extensive underground networks have posed significant challenges to the Israel Defense Forces, facilitating surprise attacks and complicating traditional combat operations. This has prompted militaries worldwide to re-evaluate their tactics and invest in technologies capable of addressing the complexities of subterranean warfare. Robotic dogs are versatile platforms capable of performing a range of tasks in military operations. Their functions include reconnaissance in hazardous areas, delivery of supplies, surveillance, and in some cases, engagement in combat scenarios. Equipped with advanced sensors and mobility systems, these robotic units enhance the operational capabilities of armed forces, particularly in environments where human presence is risky or impractical.
If you find information in this video interesting, please like and subscribe.